Hi guys, so as promised I'm gonna cover the stuff that I didn't get to cover last Friday lecture when we were talking about diode-transistor logic. So I have tried recording this before, experienced some technical difficulties with the pen, so bear with me if this comes up again. But anyhow, we've been talking about this circuit that you see in front of you here, and do you remember which gate it is? So pause and maybe try to remember. Okay, so if you figured out that this is a NAND gate, very good. This is really the only one that we've discussed. Okay, so we'll analyze it a little bit, but let's start with some simpler examples first. All right, first of all, if you look at this circuit, you will hopefully recognize it as an inverter. There is something new in it though, namely this diode. We have not put this diode at the base of the transistor before to make an inverter. So let's figure out for a minute why it's here. So remember that we understood the inverter with this kind of characteristics. This was V out, here marked as V out, and V in. Here was V in. Okay, now it's not writing. V in. All right, and V out, when in this case V in is the same thing as A. Okay, there is a border essentially beyond which I can't write. I think that has something to do with the circuit. Anyhow, if you recall, the input-output characteristic looks something like this: flat, then there's this transition region where the transistor is active, then goes like this, and it would turn on here. The turn on voltage is typically 0.7 volts. Okay. All right, so we could say, all right, until it's 0.7 volts, the transistor is not going to turn on, and we'll have high output. Okay, but remember that in logic we defined our zeros and ones on a voltage scale as such. 0 was 0 to 1 volt, and 1 was 5 to 3 volts going down. All right, so if we are turning on this inverter at 0.7 volts, we're still turning it on when the input is 0, and we probably don't want to do that. Okay, so this diode, essentially what it does is that it will add to this threshold here, right? And then with the diode here, we will not turn on until, can you think when? Okay, maybe you figured it out, 1.4 volts, right? So this region where the input is 0, it's not going to turn on. Right. And we can make sure, we can size the resistors properly, but we can pretty much make sure that somewhere above 3 volts that the transistor is in saturation and the output is low. All right, so this is the inverter as it's made for logic, and I'll continue the video in a minute with a new video. Okay.